Alright, so we're just going to summarize what we learned about linked lists. So this is sort of the implementation that we wrote for our linked lists, singly linked list with one value stored in each node. And over the past many videos, this is everything that we implemented. So we built a class that has two private member variables keeping track of the size of the linked list and the front of the linked list, and it has a private struct. You can't use this struct outside of the class. So a lot of the code that you've probably written with linked lists allows you to like send pointers in or take them out, but the way that we're building our classes is we're trying to abstract out any of those pointers. So we don't want the user to necessarily know about those pointers. We just want them to be able to use the class with whatever behavior we're interested in. So the functions that we wrote are two constructors. The first constructor is just setting up a empty list that doesn't have anything in it and no memory is allocated. And then the second linked list structure is able to take user input to fill up a linked list, and that is going to be O of n. It's going to depend on how many values the user inputted. We also set up our parameterized constructor to work assuming that n was greater than 0, so it would not work if n was 0, or it wouldn't be no allocation. It would have allocation associated with it with the way that we wrote it. We wrote a destructor. Our destructor is also O of n because we have to walk through the whole list and delete everything. We wrote a function that traverses the list and prints it, which is also O of n. And then we wrote a insert and a remove, which are also both O of n. They're O of n because we had to locate a index, and so we had to walk through the list to find a location. Remove and insert are O1 operations on a linked list if you know where you would like to insert or remove. So if you have access to those pointers, that operation is O of 1, because you just have to update the links. If you don't, then it's O of n. One of the things that we're not really going to be too concerned with writing our linked list class is efficiency, because linked lists are not very efficient if you use them in many, many ways. They can be very efficient, and there's lots of really efficient uses of them, but in general, if you just are trying to replace an array, they're not going to be any better than an array. They're just going to have like a lot of ON behavior. So you'll notice that as we talk about linked lists, that we're going to be slightly dropping the case of complexity because everything is basically O of n. And in some cases it's even worse than O of n, particularly with the cases of like inserting or removing large chunks of lists, because you have to like walk back and forth on the list quite a bit to just get everything linked up. However, you do need to be as efficient as possible. So you don't want to be doing anything like egregious where you're doing things repetitively, but there isn't like really too much you can do, I mean, not that I know of, that you could do wrong with efficiency in a linked list, unless you're just like walking through it exhaustively. Or if you are using recursion, that's a big way to be very inefficient with linked lists, because linked lists, when they're really long, because of these ONs, you are going to build n stacks, and for really, really long lists, that's super inefficient. Recursion is really, really great on link structures, but what you'll see when we start using trees is we're recursing on trees, which is log n. And so, we don't reach the like limit of the stack so quickly. So it's good to practice just to get a hang of recursion, but in the actual implementation, you don't want to use recursion for these functions on long lists, which is what we're going to be doing. All the code that we have written and used for this week is found on this link here. It can be really useful to have sample code when you start writing your own classes, so you can refer to this as you need to. So that's it for week 7. Good luck with implementing linked list class and remembering all about pointers. Sorry, couldn't hold it until I stopped recording. See ya.